It's first thing in the morning and it's time for breakfast. How many things that use electricity can you see?
Breakfast, darling.
That would be lovely.
You look like you need waking up.
So in this video, there are many things that use electricity. Mu'taz, what are the things that use electricity in this video?
Like the microwave, the toaster, the phone, and also the clock, and the time and the timer, and also the TV, and
Okay.
also I saw.
Okay, thank you, Mu'taz. Thank you. Let's see, Mohsen.
Sorry, my mistake. Mister,
Yes.
is this supposed to be a lesson, or is this supposed to be like we watch Mr. Bean?
No. This is a lesson. Things that use electricity. So Mohsen, say.
Why are we
so,
why are they like crazy? Like
no, it's like examples for the items that use electricity. So what are the things that use electricity in this video?
Toaster.
Mu'taz said toasters. Give me more. Calculator. Huh? Magnet. Maybe the magnet and some items. Okay. But the magnet doesn't use electricity. Copper. No, the items, the devices in this video.
Toaster, microwave. Calculator, you already said that. The switch is for the light.
Ahmed? Okay, thanks, Abdul. Ahmed?
Yes.
What are the devices that use electricity here?
You know the air dryer?
Air dryer, yeah.
Yeah, we use it to get electricity.
What
we
else?
get electricity to do it with our hair.
Yeah, what else? The light.
And also, yeah, the lights. We press
the
a
fridge.
button and it
The fridge. The fridge.
yeah,
The car.
We basically can't not use electricity. We need electricity in our life.
Yeah, we cannot live without electricity.
Yes.
You said microwave, you said fridge, you said washing machine,
Yes.
you said toaster,
Yes.
we said kettle.
Yes.
Yusuf, you know what are the devices that use electricity?
Devices.
Hmm.
Maybe speakers,
Hmm.
computers, laptops, iPads, iPhones,
Yeah.
MacBook.
Many things.
What is there anything else than the computer, iPhone, and iPad? Is there
Yeah.
anything else?
Yeah. So now please open
Like what
page 517 quickly. 517.
Okay.
517. Ammar,
Yes.
Ammar, here, what types of energy is electricity being changed into in this picture?
Do I have to read something?
Yeah.
Electricity is being changed into sound and heat energy.
And heat energy. You know how? The sound. This singer uses a microphone to make her voice loud. So this mic uses electricity, you know?
Yeah.
So we will change electricity to be sound. So electricity is being changed into sound and heat energy. Write it. This is page 517. 517. Electricity is being changed into sound and heat energy. Ten seconds to finish your writing. Electricity is being changed into sound and heat energy. And this page is 517. Yusuf Oda?
Yes.
Okay. What are the vocab of this lesson?
Okay. Electric motor, magnet, electromagnet, generator.
Generator. Done with writing?
Yeah.
This one? You wrote electric motor, magnet, electromagnet, and generator?
Yeah.
No. Write them.
I did.
I just open it for you. Jamel,
Yeah.
is it clear on my screen?
Yeah.
Last night, I was in my room taking a quick break from doing homework when all of a sudden everything went dark. It surprised me. Mom yelled up the stairs, "It's okay. The power just went out." Luckily, the power came on 5 minutes later since I had a book report that was due the next day. Click the hotspots to learn what was affected by the power outage. When you're done, click Next to learn more about how we use and depend on electricity. Everything went dark. None of the lights worked since they are powered by electricity. Luckily, I had a flashlight in my nightstand, so I could use that to see. Mom picked up the phone to call the electric company to report that our electricity was not working. But our phone did not work because it is plugged into an electrical outlet. Luckily, my cell phone is powered by a battery, so I could text my friend to see if his power was out too. Thankfully, a battery also powers my new desktop-laptop combo, as I had just typed a great paragraph and hadn't saved my work yet. However, the battery lasts only 2 hours. Then I need to plug it into an outlet to recharge the battery. Welcome to the lesson, How Do We Use Electricity? You'll explore where electricity comes from and how you are able to use it to do things. The vocabulary words for this lesson are generator, electromagnet, electric motor, and magnet. Click each word to find out more about it.
Generator. A device that makes an electric current by converting mechanical energy to electrical energy.
Abdullah?
Yes.
What is generator?
Generator is like the
A device?
teacher, the screen is blurry.
Okay.
Far away. Okay, it's a device that makes an electric current by
Converting?
converting mechanical energy to electric energy.
Electrical energy. What are the mechanical energy here? The mechanical energy, the movement of the wind. The wind makes these fans to move. So they are mechanical energy. This mechanical energy will change to be electrical energy. So this is called generator. Again?
Generator. A device that makes an electric current by converting mechanical energy to electrical energy.
All right. The second?
Electromagnet. A temporary magnet caused by an electric current.
Jamal? Ahmed?
Yes.
Electromagnet.
Electromagnet. A temporary magnet caused by an electric current.
Read that.
A temporary magnet caused by an electric current.
Electric current. That's right. Next.
Electric motor. A device that changes electrical energy into mechanical energy.
Faisal?
Yes, teacher.
Electric motor, this one.
Electric motor is a device that changes electrical energy into mechanical energy.
Like this fan. Look.
Yeah.
This fan will change the electric energy to mechanical energy of movement. You can see the movement of the fan.
Yes.
The last one, magnet.
I mute?
Yeah.
Magnet.
Okay.
An object that attracts iron and a few other, but not all metals.
Danny. Mohsen.
Mister, this is the thing that I can get from the cornflakes. The
Yeah.
iron filling.
Magnet? How?
Yeah.
Explain
The
it for
iron
us.
filling. It's science.
Yeah, how? How? What is magnet first?
Now, this is an object that attracts iron and all metals and metal, but
Few other, not all metals.
not all metals.
Not all
Mister,
metals. Yeah.
it's science. Somehow they say if you put cornflakes in a paper and crush it in a bowl and crush it into powder and put the crushed cornflakes in the paper and use a magnet, you will get iron filling.
You did this experiment?
Not yet.
So can you do this
Because I don't
experiment
want to take
and
it
make a
home.
video and send it for me? Then I'm gonna
Because it's
share it
hard
with
to
us,
play with
with you. Huh?
Because I didn't want to do it with food.
You can try with few amount.
Okay then.
Wouldn't it be cool if the moon were covered in
Actually,
light
the
bulbs you
book.
could turn on from a switch in your room? But the moon is far away. Getting there would be like traveling from New York to California almost 100 times. It seems like it would take a really long time for those lights to turn on, right? Actually, you wouldn't be waiting long at all. Only a bit more than a second. To get those moonlights on from the switch in your room, you would use electricity. And electricity travels very, very fast.
Okay. So we said electricity travels very fast, like the fast of light, the speed of light. You know what is the speed of light? Can anyone tell me what is the speed of light? Jamal, you know what is the speed of light?
Yeah,
What is the speed of light?
like from the sun, the light
Mhm.
comes super fast to the earth. That's how we see everything.
Yeah, in only 8 minutes, you know?
It reflects from the moon to the earth, same way
The light can travel in space
to the moon.
300,000 kilometers in 1 second.
Yeah, but the
300,000
speed of
kilometers?
light, it cannot escape a black hole.
Yeah. Yeah, exactly. You know about black holes?
Yeah,
Yeah, perfect.
in like a few billion years, it's gonna come to the solar system.
Yeah.
Thank God I don't have to deal with that.
Electricity is useful because it can be transmitted easily and it can be changed into so many other helpful forms of energy. Click the pictures on the right to learn more.
I'd never deal with that.
Yusuf?
Am I also? No, that'd be the worst. Yes.
This dog, I think he's feeling cold. So
Yeah.
what is the importance of electricity to this dog?
That he wants to get warm.
Yeah, so electric energy to heat. So we're gonna change the electric energy to be heat energy.
We can use fire, but it's dangerous. We
Yeah.
can use the fire, but it's dangerous. We can use electricity too.
So if you
Like
talk
in
about fire,
Finland.
if you talk about fire, so it's changing from chemical energy to heat energy. But here it's from electrical energy to heat energy.
Okay.
Thanks. Mu'taz?
Yes,
Look at this girl and say from what energy to what energy.
Everyday flashlights turn electrical energy into light and a little bit of heat.
Huh?
See, there is two energies. Light energy and heat energy.
From what energy to what energy we change?
Oh. First thing, from light energy to heat energy.
No, from electrical, because you know this torch is using a battery. Use a battery inside it. So the battery is electric energy. We change the electrical energy to be light in the end. Okay?
Okay.
Manef?
And,
Yes, Mr.
the next
I
picture.
am here for helping everybody.
Okay, the little scientist.
Yes.
Listen.
This music system turns electrical energy into a lot of sound.
What kind of transforming here?
Yeah.
From what to what?
From
All of
Like
them
how?
from electrical energy. Here, the outcome will be sound. You know, this is recorder or radio or something like that, cassette. So from electrical energy to sound.
It is electricity sound, like kinetic energy. Yes.
Kinetic? No, it's not kinetic energy.
No.
Mechanical?
Yeah, mechanical.
No, it's not mechanical energy. Mechanical energy when we find movement here. Is there any movement here?
No.
So when we plug electricity, the electrical energy will change to be sound in the end. So we can hear the sound from this radio.
Yeah.
Thanks. Ahmed, the last picture.
Yeah.
Electric engines turn
Yes,
electric
master.
energy into motion. This is a hybrid engine that uses both gasoline and electric power.
What kind of a change here, Ahmed? Ahmed,
Yeah.
what kind of a change here in this motor? The motor of the car.
In this water, it's a PC. It's flowing into it's flowing to make energy.
What energy in the car?
Mechanical energy.
Mechanical energy. So electrical energy will change to be motion.
Yeah.
Thanks.
Did you ever wonder why a compass points north or a magnet sticks to a refrigerator door?
Abdel Mohsen, your best here, the magnet.
Magnets work because the magnetic field interacts with the metal in the refrigerator door. Click the highlighted areas to learn more about magnets and magnetic fields.
Yes, mister?
You like magnet. So what happened here?
A magnetic
Magnetic field.
yes.
You can see the attraction.
Yes,
Or
because
the-
of the magnet.
Yeah,
Like-
so in magnet we have south and north. South and north. Look, this is N
South is negative and the north is positive.
or the opposite. So we have N and S. N stands for north and S stands for south.
South.
And we can see here the magnetic field. So let's learn more.
Did you ever push magnets across a table and you place two of the same ends near each other? When the north end of a magnet gets close to the north end of another magnet, they repel each other.
Yes, Mohsen?
Mister,
Yeah.
we put iron filling in the middle and we put north and north facing at each other.
Yeah.
Will they both attract to the same iron filling?
Yeah.
But how? They can't
Magnets
connect
have a north-seeking and a
the same, they
south-seeking pole.
repel.
The north-seeking pole, or N pole, of a magnet
Let me
is
show-
attracted to the south-seeking pole, or S pole. The area around a magnet where magnetic forces act is called the magnetic field.
So if we have north and south, they will attract. If we have north with north, they will repel. If we have south with south, they will repel as well. Yes?
I'm saying, like, if we had the same amount of iron filling in the middle and the same and north and north. will
North and north, they will
connect?
repel. They are too
No, will they
similar.
connect the
They are
iron
too similar.
The iron filling will connect to one of them, but they can't because they're the same. But how? I
It
don't
will be
understand.
included. It will be included in the middle. In the middle, it will attract to one of them, the strongest one. But if they are the same amount of electromagnet or magnetism inside it, it will be between them, like that. Listen.
The magnetic field turns each iron filing into a tiny magnet. The filings line up with the magnetic field. Have you ever held up your schoolwork on the fridge with a magnet?
Okay.
The magnet and the metal of the refrigerator attract each other. Have you ever used a magnet to pick stuff up? An electric current running through a wire makes a magnetic field. The wire is just a weak magnet, but it can be made strong enough to pick up stuff just like any other magnet. Click the pictures to learn how electromagnets can be used.
Oh, we use magnet in many things in our day life. So we can use a magnet with electric, and that called electromagnetism. Let's see the first one, electromagnet.
If you wrap a wire around a piece of iron, you get an electromagnet. If you wrap lots of wire, the electromagnet will be even stronger. See the needle on the compass moving? The needle inside the compass is a magnet. The current running through the wire makes an electromagnet. The magnetic fields attract each other and the compass needle moves.
Muhammad Sultan, you know what is the importance of compass?
Yes.
This one. Why this one is
The
important for us?
It tell you
The directions.
east, west, the direction east, west, north,
South, west,
south,
north,
southwest.
south, east, west. You know, this needle inside it is magnet. This needle inside it.
And red, red and white, it's magnet.
Yeah, this needle is magnet, and this is always refers to north. North N. If you change in motion, if you change your direction, it will change with you. Then motor.
Motor, I will tell you this motor.
Humming sound as you watch the blades of a fan move. This is the sound of the motor. The motor inside the fan makes the blades turn. An electromagnet inside the motor causes this movement, changing electricity into the energy of motion.
Also, inside the motor of this fan, we find magnet.
There's magnet, but we don't see it inside the.
Yeah, it's inside the motor.
fan.
The motor of this fan.
Pushing the button on a doorbell closes a circuit. The electromagnet pulls the striker into the bell to make sound. This happens again and again while the button is held.
Yes, Muhammad?
No, the door, when you see this